In this video, we would like to find something about specific resistance and try to understand what is it. It's also called as resistivity. What is it? To know something about specific resistance, first we shall talk about resistance. We know resistance is something that opposes the flow of current. So every material has some opposition which is measured using resistance. That resistance, which is represented R, depends on the physical dimensions of the material. That's directly proportional to length, inversely proportional to area of a cross section. So whenever wire dimensions changes, like it's iron 1 meter have one resistance, iron 1 millimeter will have one resistance, iron 10 meters will have some resistance. Similarly, same material of different areas also will have different resistances. That's a block. That's a problem, because for iron I cannot say this is the value. Rather we have to say what is this. We have to ask what is its length and what is its area of cross section is. To avoid that problem, we have eliminated this proportionality, put a constant called rho, where that rho is called as specific resistance or resistivity. But be careful, here rho is a proportionality constant. Whenever you say proportionality constant, that rho is obviously independent of length, independent of area of cross section. Rather depends on whom. This rho depends on nature of material. So for iron, we'll have a single rho, whatever maybe its length is, whatever maybe its area is. Now you have got the advantage of rho instead of R. When you say rho, it is same for a given material under all circumstances, whereas resistivity is same, but the resistance is different. So when we need a single parameter which is same for all of them in respect of their dimensions, I can use a word resistivity or specific resistance. That's why we need rho. So what are the units and dimensions of that resistance? Let's try it. R equal to rho L by A. You know, resistance is measured with a unit ohm. For rho we have to find out. Length is meter, area is meter square. 1 meter gets cancelled. That implies rho is having a unit of SI unit of ohm meter. That's the SI unit of rho. If you want a dimension also, we can find out. But to find out a dimension, we need to know some other things. R equal to rho L by A. So I need to know what is the dimensions of resistance. So let's try to find out what's the dimensions of resistance first. Resistance we need to find out. I can find out using a formula V equal to IR. You know, V is the potential which is defined as work done in bringing a unit positive charge from infinite distance up to one point. I is ampere, which is a fundamental unit in SI system. I need not find out. For resistance, we have to find out. Further, we can write Q as IT, because I equal to Q by T, equal to I into R. So for R, we are having a formula of work done. If this I can go to the denominator. Then it becomes work done. It is not work done square, work done divided by I square and T. You know the formula for work done as ml square T power minus 2. I you can call it like say ampere square and T. So resistance has a dimension of ml square T power minus 3 ampere square, or I square you can say. That has, you can show it like I also as you wish, right? So R m L square T power minus 3 I power, I is in denominator, so I will become m minus 2. I know the resistance now. We can continue further using a formula R equal to rho L by A. I want the dimensional formula for rho. So for R, I have just now identified a dimensional formula. What is that? M L square T power minus 3 current power minus 2. For rho, I have to find out length is L, dimensionally area is L square. When L and L gets cancelled. So rho has a dimension of ml square T power minus 3 I power minus 2 into L. So dimensional formula for specific resistance or resistivity is m L square T power minus 3. L square and L is there and L is there. So L power 3 and I power minus 2. That's how we can talk about specific resistance. That's it.